All right. Now we're ready to start. Okay, so judging from how well you guys did on the quiz, for the most part, okay, you should be pretty well prepared then to be able to graph the rest of these trig functions, secant, cosecant, and cotangent, okay, which is good news because, you know, it should be pretty easy. And, you know, they look kind of funky, the graphs do, but there's going to be like basically two key things, at least for secant and cosecant. The two key things that we want to remember here is the relationships to sine and cosine. So secant, okay, of x, remember, is equal to 1 over what trig function? Cosine, okay, cosine of x. And again, it's like one of the silliest things in math that one of the silliest namings in math. Why is secant 1 over cosine, or why is cosine 1 over secant, right? Why is that so? Well, that's just how it's defined as far as I know. And cosecant of x is equal to, is the reciprocal of what trig function? Sine, right? Sine. So 1 over sine. And we'll talk about cotangent here in a second. But of course, well, I guess I might as well just finish it off, right? Cotangent is just 1 over the tangent. So we'll focus first on, like I said, the secant and the cosecant, though. That's what we want to look at here. So let's talk about just graphing plain old secant of x. Okay, let's graph plain old secant of x. And the way that we're going to do that, okay, is we're going to actually start by, we're going to compare that, I'll go ahead and do that, versus, we'll compare it to its reciprocal trig function, cosine. And hopefully that will kind of help us, to come up with a graph of secant. So the first thing we'll do is we'll graph cosine. Cosine should be something we're familiar with. And we'll go ahead and we'll do 2 full periods here just to kind of get a good idea about what's happening. Okay, I'll do cosine in black, and then I'll do the secant in red here. I do have a red pen. Oh, picked up the wrong one. So I'll do secant in red. So if you want to use 2 different colors or something like that, that's up to you, but I'm going to do that. Okay, so cosine, we know, starts at 0, goes to 2 pi for 1 full period, and then we'll go out to another 4 pi there to get the 2 full periods in. Okay. Remember, for our amplitude is 1, and there's no vertical shift, so we're just going to go from -1 to 1. And we got to find the halfway point, so pi, and then the quarter point, so pi over 2, and then 3 pi over 2, and then 3 pi here, and then 5 pi over 2, and 7 pi over 2. So full period there. Okay. Right, and then cosine, we know cosine of 0, that starts at 1, so cosine of 0 is going to be 1 there. I don't think I quite made that low enough. We'll do it like right down there. Cosine of 0 is 1, and then cosine of pi over 2, that's going to be 0. And then cosine of pi is -1, and then we can kind of just keep going there. So 3 pi over 2 will be 0 again. Cosine of 2 pi is 1, 0, -1, 0, 1. Okay. And this will be our general strategy for graphing secant. So anytime we go to graph secant, we're just going to swap secant and cosine. We're just going to, like, so if we see like secant of x plus 1 or something like that, we see a shift or anything like that, we'll just swap secant for cosine, we'll graph the cosine, and then we'll figure out the graph of secant based on the graph of cosine. Okay? We'll figure out secant kind of based on the graph of cosine. So what do I mean by that? Well, if we look at our graph of cosine here, right, for example, cosine of pi over 2 is 0, right? Cosine of pi over 2 is 0. But if secant is equal to 1 over the cosine of x, okay, that means that secant of pi over 2 is equal to 1 over the cosine of pi over 2. Okay. Okay? And we just saw here in the graph that cosine of pi over 2 is 0, so therefore what's the value of secant of pi over 2? Undefined, right? Yeah, if cosine of pi over 2 is 0, then 1 over cosine of pi over 2, 1 over 0, that means secant of pi over 2 is undefined. And to denote that being undefined, right, for our secant graph, that means we're going to have what kind of thing here? We're going to have an asymptote. Okay, we're going to have an asymptote occur in our graph of secant at pi over 2. Well, where else in these two periods are we going to have asymptotes? Where else then when we have asymptotes? Using a similar kind of logic there, where else are we going to have asymptotes? Yeah, all zeros. So 3 pi over 2, because the reciprocal of 0 is undefined, so we're going to have asymptote there. Asymptote at 5 pi over 2 as well, again, for the same reason. And asymptote at 7 pi over 2 for the same reason. Alright, so the graph of secant is going to have asymptotes. Okay. Now, we also know some other pieces of information here. For example, that are some easy calculations to do. For example, at 0, cosine is 1. So that means the secant of 0 is going to be 1 over the cosine of 0. Right? But cosine of 0 is 1, so secant of 0 will be 1 over 1. 1 over 1, which is just 1 again. Right? The reciprocal of 1 is 1. So if at 0, cosine is 1, the reciprocal, secant at 0, will also be 1. So we have this point also on our secant graph, which means then at 2 pi, we will also have that point on our secant graph, and at 4 pi, we will also have that point on our secant graph. So those points all exist. And then also for like pi and at 3 pi, so at pi and at 3 pi, well, the y value there is -1, but what's the reciprocal of -1? What's the reciprocal of -1? Well, think about -1 as a fraction, -1 over 1. The reciprocal would be 1 over -1. So what's the reciprocal of -1? -1. Yeah, no surprises. It's just -1. So this point here at pi, right? Cosine of pi is -1. The reciprocal, which would be the secant at pi, would still be -1. Okay. 3 pi as well, -1. So it's like, all right, is this going to be the same exact graph? Well, it can't be the same exact graph because we have asymptotes instead of zeros here. All right. And how do we come up with the rest of this graph? Well, we can think in other terms. So we can think, for example here, at pi over 3, okay, so maybe I'll kind of squeeze this one in here. Pi over 3 would be like right, I don't know, like right here, I'll say. Zoom in on that some. Okay, if I put in pi over 3, what's cosine of pi over 3? What's cosine of pi over 3? It's going to be. What's cosine of pi over 3? 1/2. Right, 1/2. So then what would secant of pi over 3 have to be? 2, the reciprocal, 2, right? So cosine of pi over 3, if we kind of look here, we can kind of convince ourselves, yeah, that's about halfway between the 0 and the 1 there. So cosine of secant of pi over 3 is going to be like up here. Let's see, that's 1. Let's say it's like right there. So then it's going to be like pi over 3, it's going to be up here somewhere. Okay. So if I kind of like that. Okay, it's going to go up to that point there. Okay. Similarly, at like at 2 pi over 3, what's cosine of 2 pi over 3? Cosine of 2 pi, so that'd be like roughly like right there. What's cosine of 2 pi over 3? What's cosine of 2 pi over 3? -1/2. And so then what's secant of 2 pi over 3? What would secant of 2 pi over 3 have to be then? -2, yeah. So at 2 pi over 3, we're going to be like roughly right there. Okay. I'm doing the pi over 3s because those are easier calculations than like trying to figure out what the reciprocal of, you know, square root of 3 over 2 would be, or just reciprocal of like root 2 over 2, what that value would be. It's easier for the 1/2. Okay. But then, of course, besides 2 pi over 3, we also have 4 pi over 3, which would be like, I don't know, like right here, we'll say something like that. Okay. And that would also be negative 1/2, which would also give us a negative 2, so something like down here. And so it's going to look something like that. Okay, oops, sorry, I'm like going off there. And then hopefully at this point we can kind of see that, well, the idea is it's just going to repeat. So we kind of just keep drawing here, and we're going to end up with this kind of graph. And the idea being that there would be more. Like that. Okay. So it's kind of hard to imagine here because we have both the cosine and the secant at the same time. But the red is the secant. The red is the secant. Okay. For those of you with like pencils and stuff like that, you know, when you're doing these problems, I recommend erasing away the cosine, you know, so that way you just have the secant graphed up there. So. But if we go to our graphing calculators, we can see that in fact we do get something that looks like that. Oh, there it is. Well, beauty is in the eye of the beholder, I guess. But you know, yeah, it's not the prettiest thing, I guess. That's right. Go to zoom trig. Yeah, so there it is. Okay. So that can be quite intimidating to think about. Okay, to like think about graphing and stuff. But like I said, if I throw in a cosine here to compare it with, you can see the same kind of behavior that we kind of like figured out, right? So there's a 0, and look, there's an asymptote for the cosecant, right? There's a 0, there's an asymptote. 0, asymptote, 0, asymptote. Okay? You can even mess around with this here. I make like cosine. Actually, I should do it the other way around. Maybe make this one thicker, and then this one I'll just... there we go. Of course, you with those like fancier calculators, you can like do different colors and stuff. You see it here? I'll thicken that one so you can kind of see. But yeah. So the negative ones, their reciprocals are 1 and negative 1 still, so those values stay the same. That's the ones that are shared between the two. The zeros become the asymptotes, and then we have there's that cosecant. Okay, so that's the idea. All right, questions on any of that? Secant, or cosecant, I should say, cosecant is the same kind of idea. Cosecant is the same idea, except we're just going to use sine to graph it instead of cosine. It's the same idea. Okay, so let's just jump into some transformations here. Let's see. In fact, we'll jump into and do a cosecant one here. The good news is, okay, and we're just going to do, we'll just do one full period here. Okay, so graph y equals the cosecant of x plus pi over 4 for one full period, over one full period. Okay, so here we have a shift, a horizontal shift, and that's it. All right, so how does that affect things, right? Well, it affects things just like the way we affect it with sine in this case, right? So rather than graphing cosecant of x plus pi over 4, we're going to start by graphing sine of x plus pi over 4. So we're going to start by graphing the reciprocal of cosecant, sine, and then we'll use that to help us graph cosecant. Okay, that's going to be our goal here. All right, so let's do that. So I'm going to make our adjustments. So we'll do from 0 less than or equal to x plus pi over 4 less than 2 pi. So again, we want to still keep that period 0 to 2 pi, right? That's still the same. And then we'll just, do our calculation. So we're going to subtract pi over 4. So we get negative pi over 4 less than or equal to x less than, and then that will be 7 pi over 4. Okay. And then alright, so I'll put like the negative pi over 4 here. 7 pi. Okay, put the 7 pi over 4 there. And so we want to find then our, halfway point and our quarter points, just like before. So remember, at this, with these kind of calculations, it can be kind of tricky because you maybe can't mental math it, but you can kind of, to find the midpoint of this interval, right, we're just going to add these two numbers together. So negative pi over 4 plus 7 pi over 4, that's now 6 pi over 4, which is really just 3 pi over 2. And then half of 3 pi over 2 is 3 pi over 4. So, okay, 3 pi over 4. That's the halfway point. And then halfway, the quarter points, the halfway between the halfway point, right? Okay, so add those together. Negative pi over 4 plus 3 pi over 4 is 2 pi over 4, which is really pi over 2. Half of that is pi over 4. Okay, and then halfway between 3 pi over 4 and 7 pi over 4. So 3 pi over 4 plus 7 pi over 4 is 10 pi over 4, which is really 5 pi over 2. 5 pi over 4 then is the halfway point. Okay, our amplitude here is still 1, so no changes there. Okay. And so now we can go about graphing sine. So go ahead, graph sine real quick. I'm going to grab a pencil so that way I can write this. So go ahead and graph that sine real quick. And then if you feel comfortable with it, go ahead and go ahead and try graphing the reciprocal trait function too. All set up, go ahead and graph it. Alright, so sine of negative pi over 4, add pi over 4 is 0, so sine of 0 is 0. And then skip the 0, right? 0 is not a point with the pi over 4. So then pi over 4 plus pi over 4 is pi over 2. Sine of pi over 2 is 1. And we go back to the 0 and down to negative 1 and then back to the 0 there. So these points, and so sine's going to look like this. Okay, so you got your sine graph in there, and now wherever we have our zeros, okay, wherever our zeros are on our axis, those are going to be our asymptotes. So we're going to have an asymptote at negative pi over 4, 3 pi over 4, and 7 pi over 4. Again, the reason for that is because if we have a value of 0, then the reciprocal of 0 will be undefined. So those are all going to be asymptotes. We also have the points, at pi over 4 it's 1, so then at pi over 4 for the cosecant it'll also be 1. So you can put a point there. Same thing with the negative 1. At 5 pi over 4 it'll be negative 1, so basically at the peaks and the valleys there, okay, at the maximums and the minimums, those points will remain. Okay, so the maximum point at pi over 4 will still remain a point for the cosecant, and then the minimum point at 5 pi over 4 will also remain a minimum. At this point, you don't really need to come up with other points. We can just kind of just say, okay, it's going to go up like this, and up like this. like that, down like that. Okay. And that's good enough for our sketching that we're going to be doing here. And then I can erase away my pencil. Nice looking graph. Okay. Because really that sine is just to help us graph it. It's not part of the actual cosecant graph. And so that's why I like to draw the sine in there to help us, figure out what we need, and then we erase it because it's not really part of our graph. So you really should erase it, okay? Please do not, when you're graphing this on your own or when you're graphing it for the test, don't leave sine or cosine on there. You'll probably lose points, okay? Unless I'm feeling like super extra kind that day. All right, so there. Questions on that? All right, how do you guys try one then on your own? So here we go. And then we'll look at cotangent, which is even easier than these two. Okay. So here I'm going to have you all graph. Y equals the secant. Yeah, okay. 2x plus 3 pi plus 1. Okay, so that's what I want you guys to try. And let's just do, I don't know, 1 full period. Okay, don't forget about that vertical shift you got there too. Don't neglect that when you're doing your graph there. So then, yes, exactly. These are still going to be 0. So now, wait, let me check this. Sorry. Okay. Should be, let's regret. So remember, secant, reciprocal is, we're doing cosine. So where cosine starts, up here. Cosine would be here, and then be the 0, and then down to there, and then back up to the 0. So you just adjust. Oh, okay, but, okay. Oh, okay. Well, if you plug this here. Oh, I see. Okay. Okay. I got you. Okay. Okay. Because they're 0. 0 plus 3 pi. 0 comes to 0 plus 3 pi is cosine of 3 pi is negative pi plus 1 would be the 0. So it should be 0 here. That 0 should be 0. You see what I'm saying? And then you have to adjust that. Okay. Not sure? Okay. So, alright, so again, remember you put this between 0 and 2 pi. Put that between 0 and 2 pi, right? And solve it. Yep, that was okay. That was pretty. You got a good guess. That's right so far. So then let's see here. And you found that. That's good. Now, to find the midpoint here, that's not quite the right midpoint. So yeah. So negative pi is the same thing as negative 2 pi over 2. Thank you. Is this for today? Wonderful. Is this from the TJ stuff too?
Yeah. I just found it on something and added a prime at the end.
Okay. Thank you. So that's negative 2 pi over 2, right? So plus that would be negative 3 pi over 2. So divided by 2, negative 3 pi over 4. So that's negative 3 pi over 4. And so this would be negative 5 pi over 4. Because we get negative 2 pi over 2 plus negative 3 pi over 2 is negative 5 pi over 2 divided by 2. Negative 5 pi over 4. How do we do? So, that's right. You need to come up. So I think.
I know, I forgot the.
So that's your starting and stopping point, right? Or that's your starting and stopping point. Yes, okay, that's what you're saying. So then you want to find the halfway point here and the halfway point here, right? So add them up, right? So that negative pi is the same thing as negative 2 pi over 2 plus negative pi over 2 is now negative 3 pi over 2. And now you negative 5 pi over 2. Okay. Alright, cool. Cool. Let's see what we got here then. So, what we're doing should look something like this here. I should erase my old one, I guess. Okay. I made a mistake, that's why I had to do it on a separate sheet of paper there. So again, we take our 2x plus 3 pi, put that between 0 and 2 pi, right? Solve for x, that means subtract 3 pi from both sides, you get this. Divide 2 by 2, you get that, okay? Negative 3 pi over 2 to negative pi over 2. And so then on our axes here, and I really smushed it all in there. But there, we're on the negative part, right, of the x-axis, so negative 3 pi over 2, negative pi over 2, so we've got to find our halfway point, negative pi, and then our quarter point, that's negative 5 pi over 4, and that's negative 3 pi over 4 right there. Okay? Now, we're shifted up 1, so I like to also draw in my little axis there, for the since we're shifted up 1, and then I drew the cosine graph. So cosine, when you plug in negative 3 pi over 2 here, cosine would be 2, okay, it's 1 off the axis there, and then to the 1, and then down to the 0, and then up to the 1, and then back to the 2 there. Okay, like that. Okay. So then the asymptotes are going to occur when we cross that axis. Not when we touch the x-axis, but when we cross the axis. Okay. The reason for that is you actually get 0, like the cosine, the trig function here will be 0 at these points, and then you add 1 to kind of shift it up. So these are like really like the zeros there. Okay, the negative 5 pi over 4, the negative 3 pi over 4. When you actually plug that in, and then you would take the reciprocal of cosine, it would be undefined. And so that's why the asymptotes are really here. So right there and right there are your asymptotes. The negative 5 pi over 4, the negative 3 pi over 4. Okay. And so there's the graph. And I like to draw in kind of like the rest of the, like the U there for just a dotted line at least, so you can see that it does complete. Okay, it's not like half of a U, it would keep going like that. Okay. So, questions on any of that? Any questions on any of that? Or we're all just too dumbfounded to come up with anything, or we don't feel like asking a question? Alright, well, that's that. Alright. We'll get some more practice. Yes! Nick, with a question.
How do you, decide that at the beginning you do 0 is less than or equal to x, is less than 2 pi?
Okay. How do you know that? Because when we're talking, so first of all, the thing is, keep in mind that when we graph secant and cosecant, the first thing we want to graph is the sine or cosine, the reciprocal trig function of it. So if we want to graph cosecant, we first look at graphing the sine. If we want to graph secant, we first look at graphing cosine, because those are the reciprocal relationships. So far, so good? So, then why do we use that 0 to 2 pi? Because both sine and cosine, all right, we could look at them at, like the graphs, what the graph sine and cosine look like, yes? They're like waves, okay? And both of those, they repeat, right? And so we try to kind of pick a place, like kind of our starting point, our initial kind of place. And so between 0 and 2 pi, which is kind of like what we use for the unit circle and stuff like that, that's like where you get all of the values for sine and cosine that you need, and then it just kind of repeats every 2 pi after that for the normal sine, normal cosine, right? So when we go to graph a period, one full period, we start with that initial kind of period from 0 to 2 pi, okay? And then we have to adjust it in this case because there's like a stretch or a shrink and also a shift too. So that's why we start with the 0 to 2 pi. We put that 2x plus 3 pi in there and solve for x, which then gives us our new transformed initial period for this particular function there, okay? If this was just secant of x, then I wouldn't need to do this calculation. It would just be from 0 to 2 pi, and then it would repeat every 2 pi after that and repeat every 2 pi before that, 2 pi after, 2 pi before. Does that clarify for you there?
Well, and yeah, but and also for tangent.
Right, so tangent, different, okay? Tangent repeats every pi, and its kind of initial period that we want to use is from negative pi over 2 to pi over 2.
Oh.
So that's, yes, those are things we want to keep separate. Sine and cosine, secant and cosecant, 0 to 2 pi. Tangent is negative pi over 2 to pi over 2, and then we're about to now get into cotangent, which is going to be just 0 to pi. So it also repeats only every pi, but yeah, well, but it's from 0 to pi. So let's look at cotangent here real quick, and then I'll get you guys started on some practice and stuff. Okay. So, and we'll just do a basic cotangent graph because it's not, it's probably even easier than secant and cosecant. Well, not that you maybe find secant and cosecant easy, sorry, but then it's easier, I think, than secant and cosecant. So, cotangent. Okay, remember that cotangent x, okay, is equal to just 1 over the tangent of x. Okay, so that's something to keep in mind. As a result, though, so maybe not as a result, but like just for calculation's sake. So one difference, tangent of x, its period, negative pi over 2, less than x, less than pi over 2, right? Cotangent's period, we're going to be going from 0 to pi. So it still does repeat. It still does repeat every pi, right? As opposed to like sine and cosine, which repeats every 2 pi. Tangent and cotangent both repeat, have a period length of pi, but they start in different places. Tangent, we start from negative pi over 2 to go to pi over 2. Cotangent, we start from 0 and go to pi. Okay. And tangent and cotangent have a similar relationship as well. So again, I'm going to do this kind of simultaneously here, but okay, so I'll start with tangent's graph here, and I'll go negative pi over 2 to pi over 2. Okay, and we know that for tangent, right, the starting and stopping point, those are going to be asymptotes. So the tangent, I'll just make it black, and the cotangent, I'll put in red for some contrast there. Okay. We don't care too much about the y-axis. I'll go ahead and put in a 1 and a negative 1 there for our help, for some calculations we'll be doing, but we don't care too much. Okay. We know that, again, the starting and the stopping point are asymptotes. The halfway point is a 0. Alright, and we know that we kind of just graph, like this. If I want to be more precise, I do know that, for example, tangent of pi over 4 is 1, so I'm going to have a point there. I know the tangent of negative pi over 4, which is really 7 pi over 4, is going to be negative 1. So I do know that I have to go up through those points there. Okay, something like that. Okay, and pi over 4 is like halfway between 0 and pi over 2, and halfway between 0 and negative pi over 2. So tangent's going to look like that. Alright. And of course, I guess I can keep going here too, like this pi. And this would be like 3 pi over 2. Now that I'm thinking about it, it'll be helpful to do that. Okay. And so then tangent will repeat, kind of like, alright, well there's, there, and there. And so, okay, so that's all tangent. That's all tangent right there. So the cotangent we'll do in red here. And it's similar kind of thinking as we did with secant and cosecant. Okay? So for example, where tangent is 0 at 0, what will cotangent then be at 0? It will have 0. If tangent is 0, we do what's the reciprocal of 0? It will be undefined. So we have an asymptote for cotangent at 0 now. Okay. Where tangent's undefined, right? We can think of that as being like 1 over 0. Where tangent's undefined, the reciprocal of undefined, we're going to say that's 0. So where tangent had an asymptote, cotangent will be 0. And then where tangent has another 0, which is at pi. Okay. So we have asymptotes now at 0 and pi. Where tangent had zeros, cotangent will be undefined. Asymptotes, right? Where tangent was undefined at pi over 2, the reciprocal of undefined, we're going to say it's going to be 0 there, so it's a 0. Okay? So we have asymptotes at 0 and pi, and then a 0 at pi over 2. And we also want to talk about reciprocals here, too. Tangent of pi over 4 was 1. What's the reciprocal of 1, though? What's the reciprocal of 1? 1. So we'll have this point right there. Okay. Tangent at 3 pi over 4 was negative 1, but what's the reciprocal of negative 1? Negative 1. Okay? So we have these 3 points between these two asymptotes, so the graph of cotangent is going to look like this. Okay. I know that's hard to see with all the tangent and cotangent stuff going on. So what does it really look like? What does it really look like, right? There's all that with the reciprocal stuff, but let me just go ahead and draw a sketch here. Okay, so here's just plain cotangent without all the messy colors and things. So cotangent, much like tangent, you have asymptotes at the starting and stopping point of the kind of initial period, which is 0 to pi. You find the halfway point, pi over 2. Okay, that'll be the 0 of cotangent. And then your curve, rather than going up from left to right, it just goes down from left to right. Like that. Okay, that's cotangent. Okay. Simply the reciprocal there of tangent. Okay. And of course you do the same kind of adjustments. Okay. So in summary, sine, cosine, secant and cosecant, you always start with 0 to 2 pi and then adjust, right? Tangent, you go from negative pi over 2 to pi over 2. Cotangent, you go from 0 to pi. Okay, so there's 3 initial periods you'll have to, kind of have down. Sine, cosine, cosecant, and secant, they all are from 0 to 2 pi. Tangent is negative pi over 2 to pi over 2, and then cotangent is 0 to pi. And then you do your shifts from there. Alright. Alright. Any questions on that? Otherwise, I'll give you guys some here to try this. So, I have some questions here to work on. So, page 337 then, in your books. Okay, and we'll do numbers 15, 21, and then 27 to 33. And 27 to 33 are just the odds there. Okay. So, there we go.